everyone, thank you for tuning into LearnCast. My name is Praachi, and today we will be discussing the basics of object-oriented programming. If you've ever taken a computer science class, you've probably heard the term object-oriented programming, which is code based on the concept of an object. In AP Computer Science A, we use Java, which is an object-oriented programming language, and it's critical to understand how it works. An object contains data and code that describe its attributes and behaviors. An object's properties make it unique from other objects, and they are held in instance fields, which are variables of an object. An object's behaviors give it functionality, and in Java we call these methods. For example, let's think about a real-life car. A car's attributes would include its year, make, color, model, and license plate, and its behaviors could include driving, accelerating, braking, and honking. The car's properties make it unique from other cars, and its behaviors make the car useful to the driver. In the same way, programmers develop theoretical objects using code. Let's say I want to create a student object in Java to record the roster of students at school. The object properties or attributes would include the student's name, grade, and ID. Each student object would have the same property types because they each have a name, GPA, and ID, but each name, each GPA, and each ID would be different. The student's object's methods, or behaviors, are a little different from the properties. The student methods could include displaying the student's name and displaying the student's GPA. The methods for an object type, which in this case is the student, remains the same for every single student because the instructions to find the name and GPA of every student is the same. What you should take away from this is that objects of the same type can have different values for properties, but the methods remain the same for each object type. Now, you're probably wondering what I mean by an object type. An object is an instance of a class, and a class is a blueprint or template of an object. Basically, the class that an object comes from is the object's type. An object from a student class is an object with a student type. An object from a car class is an object with a car type. This means that a programmer can create an infinite amount of objects from a single class. This feature is a large reason why object-oriented programming is so useful. Let's say that we want to create a roster of all the students at Plano East. To do that, we would need a student class which provides the template for creating a student object. We only need one student class to create as many student objects as we want. In the case of Plano East, there are thousands of students, so it's much more efficient to use objects to create the student roster than individually code each student over and over again. Object-oriented programming makes it much easier for the programmer to figure out what properties and methods each student has, and it makes code much more manageable and easier to understand. So now let's focus on the code needed to create an object class. Like I mentioned earlier, an object has properties and behaviors. Properties are stored in instance fields, and behaviors are defined in methods. We code these within the object class. Remember, each object of a class can have different instance variable values, but they all have the same methods. The first part of an object class is usually the properties. To give an object its properties, we need to create instance fields. An instance field is a special type of variable that is set to private, which means it cannot be changed by an outside user of the program. This means the programmer controls how the fields can be manipulated through the methods. For a student object, we could set the name instance field to equal Bob, and the GPA instance field to equal 4.0. The second part of an object class is the methods. A method is a sequence of instructions that access the instance fields of an object, and they control how the fields can be manipulated through the methods. A constructor is a special type of method, and arguably the most important, because it allows the user to set the object's instance fields to either generic values or user-chosen values. This allows the object's properties to be unique from each other. Also, constructors always have the same name as the object class. An example of methods for the student object could include getName and getGPA, which return the name and GPA of the object it's called for. Finally, let's discuss the overall steps needed to create an object. For the sake of simplicity, I won't discuss the syntax for the steps needed to code an object, but rather the overall concepts involved in the three main steps: declaration, instantiation, and initialization. First, declaration assigns a variable name to an object type. Second, instantiation creates a new instance of a class, or in other words, a new object. And third, initialization uses the constructor to assign values to the instance fields of the object. Hopefully now you have a better understanding of object-oriented programming, which is a fundamental concept that will repeatedly show up throughout your coding career. Thank you for joining me for our review of an Intro to Object-Oriented Programming. Be sure to follow us on Spotify, subscribe to our YouTube channel, and check out our website to stay up to date with the latest releases. Until next time, listen, learn, repeat.